Hi everyone, I'm Prakash. So I've been reading a bit about how authentication and authorization systems work. So I thought I'll create a bunch of videos explaining what I've learned so far. In this particular video, I will try to demonstrate the basic concepts and building blocks for designing an authentication system. This video will be a very simplified description of authentication system. So before addressing authentication systems, let us address HTTP and its stateless nature. So HTTP is used to power the entire web. HTTP is a stateless protocol, which means that a single request response cycle is independent and isolated with other request response cycles. So on the internet, when you visit a website, it's a bit like starting a new conversation every time you click on a link or send any request to the website's server. The website basically doesn't automatically remember what you talked about earlier, and it treats each interaction separately. So you can think of it this way. So when you log into a website like Gmail, you're proving that you are you. After logging in, you can read emails, send new emails, look at your contacts, and do a bunch of other nice things. But the website, which is purely stateless, does not have any memory of your previous interaction. So even if you just logged in, it forgets that you logged in a blink of an eye. Let's take a look at an example to understand it better. Imagine you logged into your email account. You are successfully authenticated. Now you're trying to send an email to your teacher, but you won't be able to do so. It's as if the stateless website does not have any information of the previous interaction. It's like, who are you? Even though you just logged in, right? So how do we solve the problem of HTTP statelessness? This is where sessions come into play. So here's how it works. When you log into a website like Gmail, the site creates a special note just for you called a session. This note contains information about your visit, like your username and some other user information. The website saves this session information in its database, giving it a unique code called a session ID. Now, once the session is saved in the database, the website sends this session ID back to your browser in its HTTP response. Your browser would now save this session ID in either a cookie or a local storage, which are like secret compartments in your browser where you can keep important things. We'll talk more about cookies and local storage and some aspects related to the best security practices pertaining to storing important information in your user browser. We'll talk about that in another video for sure. So now you get successfully authenticated. You have the session ID in the browser cookie. Now, next time you make a request, like sending an email, your browser grabs the session ID from its cookie and hands it over to the website with the request headers. Now, the server checks the session ID. It queries its database and asks, is this session ID valid? Who is this user? If the validation is successful, then it sends that email on behalf of the user, because now the server knows that the session ID is valid and the user was already authenticated. Finally, once the email is sent successfully, it sends a success response back to the browser saying, okay, I've sent the emails that you had requested. So while sessions are pretty handy, they're not without their issues. Firstly, they hog up database resources. This especially becomes a problem when the number of users increase. It also significantly increases the latency of user requests, as each request now requires a network call for querying the database, because you've got to know whether the user is authenticated or not, right? So do we have anything better than sessions? The answer is yes. Tokens. So tokens are like magic keys to access what you need without causing so much of fuss. They're quicker, they're lighter, and they don't put so much pressure on your database. So now let's dive into the workings of a simple token-based authentication system. When a user logs in, the server does something pretty cool. It creates a token that's like a digital representation of the user, which might contain the user information. It helps the user identify the user and know that the user was already authenticated in a prior request. Let's see how. So the user tries to log in, the server generates the token, then it sends back successful authentication message along with that generated token, just like session. Just that the session was saved in a database. Here, the token is directly sent back to the browser without saving it anywhere in the server. Now, when the user sends another request to the server, it grabs the token which was stored in the browser cookie and it sends it along with the email request. So it's like a badge saying, hey, it's still me, right? You had previously authenticated me. The server looks at the badge and says, I know who you are. The user information is, because the user information is already present in the token itself. It's like a VIP pass to get what they need. So the server then identifies the user. Okay, this is the user. It was already authenticated. The server then sends the email on behalf of the user. Finally, a success message when email delivery succeeds. But there's a catch. What if someone crafty and malicious decides to whip up a counterfeit token using your user information? Let's say someone is able to obtain your user ID or username from somewhere. That person can create an exact duplicate of that token, right? And then it can send the email request to server along with the forged token. The server won't be able to distinguish whether the token is genuine, whether it was the token that the server had created, or if it's a counterfeited token, because both look exactly the same. And it's very dangerous because it's like handing a mischievous actor your identity. It allows them to step into your shoes and send emails to whomever they please. To solve this problem, we need a security upgrade or something like that. So that's where digital signatures enter the scene. We'll explore the nitty-gritty technical details of how this signature is created in another video. But for now, think of it as a seal of authenticity. So when a user logs in, the server generates a token with user information and also adds a unique signature. This signature is like a stamp of approval, and only the server and no one else has the secret ink to create it. The token with the signature is then sent back to the browser and stored in browser cookie. Now let's say even if a mischievous user gets hold of the user information, it will not be able to create the token because they can't add this special signature. So when the server receives a token in the request, it can check the user information in the token and also verify the signature. If the signature is invalid, it can discard the request and send an error message to the client. So in this case, the malicious user will not be successful. Hence, digital signatures are a key part of token-based authentication systems. So this is how a token-based authentication system works. It avoids the need for a database and also addresses all these scalability issues with session-based systems. Again, this is a very simplistic explanation of token-based authentication systems, I'll be creating a lot more videos covering token-based authentication systems in much more depth. But this is all for now. Please do let me know your comments in the comment section. But for now, goodbye. Take care. Thank you.